In our modern world, the internet has become as essential as water or electricity. It connects us, informs us, and powers our economies. But how does this information travel across the globe? Two technologies dominate the conversation: fiber optic cables and satellite internet, with Starlink leading the charge for the latter. Both promise high-speed internet, but they take vastly different routes to get there. Understanding these differences is crucial as we venture further into the digital age. Fiber optic internet, as its name suggests, uses thin, flexible glass fibers to transmit data as light pulses. These cables, often bundled together, crisscross continents beneath our feet, forming the backbone of the modern internet. On the other hand, Starlink, a project by SpaceX, utilizes a constellation of low Earth orbit satellites to beam internet access down to Earth. This ambitious endeavor aims to provide high-speed internet to even the most remote corners of the globe, bridging the digital divide that has long plagued underserved communities. The choice between these two technologies is not always straightforward. It depends on a variety of factors, including location, budget, and specific internet needs. In the following sections, we'll delve deeper into the intricacies of fiber optic internet and Starlink, comparing their technologies, performance, and potential impact on the future of internet connectivity. Fiber optic internet relies on a complex network of cables laid underground and across ocean floors. These cables contain thin strands of glass fibers that transmit data using light. Information encoded in pulses of light travels through these fibers with incredible speed and minimal signal loss, making fiber optic internet incredibly fast and reliable. The technology has been around for decades, constantly evolving and improving, leading to faster speeds and greater bandwidth. Starlink, in contrast, takes a different approach. Instead of relying on physical cables, it utilizes a network of thousands of small satellites orbiting Earth at a much lower altitude than traditional geostationary satellites. These satellites communicate with each other and with ground stations, forming a complex web in space. Users connect to the network using a Starlink dish, which receives and transmits data to the satellites overhead. The advantage of fiber optics lies in its mature infrastructure and high bandwidth capacity. However, laying down physical cables is expensive and time-consuming, limiting its reach, especially in remote or geographically challenging areas. Starlink's advantage lies in its potential to provide internet access anywhere on the planet, regardless of existing infrastructure. However, it faces challenges like signal latency due to the distance data travels to and from space, and potential disruptions due to atmospheric conditions. When it comes to raw speed, fiber optic internet currently reigns supreme. It offers significantly faster download and upload speeds compared to Starlink. This is because light travels faster through glass fibers than it does through the vacuum of space, and fiber optic cables offer a direct, dedicated connection. This makes fiber ideal for activities that demand high bandwidth and low latency, such as online gaming, video conferencing, and downloading large files. While Starlink's speeds are not as fast as fiber optics, they are still impressive, surpassing those of traditional satellite internet and many DSL connections. Starlink continues to improve its network, launching more satellites and refining its technology. However, it faces an inherent challenge: latency. Since data has to travel to a satellite in space and back, Starlink experiences higher latency than fiber, which can affect real-time applications like online gaming. The choice between the two depends on individual needs and priorities. For users who require the absolute fastest speeds and lowest latency, fiber optic internet remains the superior choice. However, for those in remote areas or those who prioritize accessibility over absolute peak performance, Starlink offers a compelling alternative. The most significant advantage of Starlink lies in its potential to deliver high-speed internet to areas with limited or no internet access. Fiber optic internet, while prevalent in urban and suburban areas, is often unavailable in rural or remote regions due to the high cost of deploying infrastructure. Starlink, with its space network, can bypass these limitations, beaming internet access to even the most isolated communities. This has significant implications for bridging the digital divide, enabling access to education, healthcare, and economic opportunities for millions worldwide. As Starlink deploys more satellites and expands its network, its coverage and performance are expected to improve. However, challenges remain, including regulatory hurdles, affordability in underserved communities, and the environmental impact of launching thousands of satellites. The future of internet connectivity likely lies in a hybrid approach, leveraging the strengths of both fiber optic and satellite technologies. Fiber optics will continue to dominate in densely populated areas, providing ultra-fast speeds and low latency. Starlink and other satellite internet providers will play a crucial role in connecting the unconnected, bringing the internet to remote regions, and fostering a more digitally inclusive world. Ultimately, the goal is to create a future where everyone, regardless of location, has access to the vast resources and opportunities that the internet has to offer.